Hello, welcome back. So, in today's lecture, we are going to study about long-term memory. This is a part of memory which has been discussed in the Atkinson-Schriffen model, and this is the kind of memory that people, when they colloquially or when a layman talks about memory, this is the kind of memory that they talk about. So, what we are going to do in today's lecture is we will look into this kind of a memory. So, basically most retrievals that you have, any kind of information that you think of storing, any kind of life event, knowledge, any kind of facts, any kind of mathematical rule or any other kind of information which you think is stored in your mind or brain is basically what is stored in the long term memory. So, let us then look at what is long term memory, and in this particular section we will look into basic processes of long term memory, as in how it is formed and what are the basic processes and kind of retrieval and all, and the upcoming couple of lectures we will look into different kinds of long term memory. Now, continuing from what we saw in the last class, I discussed about something called Atkinson and Schriffen's model. So, Atkinson and Schriffen model or the information processing model talks about a system which has three parts into it, a three-part system. So, what we have is a setup like this, and this is called the sensory register. In the last series of last lectures, we saw what is sensory register and how does it work and what are the various properties of the sensory register. So, basically any information which comes out or which comes in or gets processed through the perceptual and attentional processes basically arrive at the sensory register, and it has a huge capacity in very short duration of time. And then we have something called the short term store. This is another thing that we talked about in our last lecture. This is the kind of system which holds information for brief periods of time, not very brief, but brief periods of time, but it can hold only limited information. And we saw an extension of this concept called the working memory in our last class. So, working memory is basically an improvement of the short term store, because it talks about a system which has more capacity than as was discussed in the Atkinson and Schriffen model. And obviously, the last thing that we did not discuss, the last part we did not discuss was the LTM or the long term memory. This is the store which holds most of the information. Even the working memory, as we saw, the capacity working memory executive systems which basically make decisions for the working memory system, they through the episodic buffer connect to this long term store. So, this long term store then holds up most of the information. Now, the Atkinson and Schriffen model just does not talk about this kind of box and arrow structure, but they also talk about processes, and so these processes are the ones which actually go ahead and transfer information. So, here the process here is the attentional processes. So, I will write attention allocation here. So, that is the process which takes in information from the sensory register and moves it to the short term store. And once the information is in the short term store, it is basically the rehearsal process which moves information from the short term store to the long term store. So, the number of rehearsals that you do, the number of repetitions that you do of an information, number of times you use an information, it basically goes to something called the long term store. It gets stored here. Now, the long term store is not an active store, as we discussed in terms of the short term store. We saw the working memory concept describe the short term store as an active store. So, it can do a lot of stuff, it can move around a lot of stuff, it can do a lot of activity, but the long term store does not do any activity. It is just like a kind of storehouse which is there. So, information are there, a number of information is stored here, it is stored in a highly organized and categorized format, but there is no action as such, which basically means that things cannot be acted upon. If a particular rule or if a particular information needs some action on it, some kind of an action has to be done on this information, it has to come back to the short term store, the working memory store, and the process which moves information from the long term store to back to the short term store is basically called the retrieval process. So, basically then we will look into this part, this whole part in this lecture. Now, the question is, what is the existence or evidence for existence of this long term store. But again, let's quickly look into the idea of serial position curve. Now, what was the experiment for looking at the serial position curve? The experiment was that a list is given to people to actually go ahead and read, and once you read this list, you are asked to retrieve it back, and as you retrieve it back, what tends to happen is a curve like this is shown in terms of retrieval. So, if I look at percentage accuracy of recall, which is on this side, and this is the item numbers on the list, what I tend to see is that items which are recent tend to be retrieved more, and items which are at the beginning of the list tends to be retrieved more, whereas items in the middle of the list are not retrieved. And so, this effect was called, this was called the primacy effect, and this is called the recency effect, and very popular theory, we have discussed this before. Now, this basically experiment shows that, and that there has to be two systems of memory, there has to be two stores of memory. The reason why is that in the items which have been learned at the beginning of the list, they receive a number of repetitions, and so they are retrieved back better, is because this goes to a LTM store, a store which stores information, a kind of structure in the brain which stores information for longer durations of time. And experiments were done where it was found out that the primacy effect, items which show primacy effect were remembered for longer duration of time. Why? Because it was processed. Think of you doing the list. What happens is the first item comes in, so second item pops in, so you repeat the first item and the second item, third item pops in, you repeat the first item, the second item, the third item, and so the number of repetitions that the first item actually goes through or it receives is n factorial times. The kind of the list items is there and make a factorial of that, and that is the kind of repetitions it receives. So, with more number of repetitions, you are prone to more number of more processing, and so shifting to a store. So, this basically here, this diagram here shows you that there are two different kind of stores, and this is the short term store and this is the long term store. Now, another interesting thing is that as we saw that the short term store, which is basically then improved into the working memory store, that is divided into its central executive, the phonological loop, the visuospatial sketchpad, and the episodic memory. Similarly, the long term store has, or the long term memory has, several subdivisions. So, we look into the subdivision in the as we move progress through this, and each of this subdivision we are going to look at, or we are going to study one by one. So, in the upcoming lectures we will look into all of these stores. So, basically there are two subdivisions of it. One is called the declarative part and the other is called the procedural part. So, basically the long term store in itself is divided into two stores. There is a lot of debate. We will also look at the debate of what the declarative and procedural part is, but basically the difference is declarative is that part, or the declarative is that type of long term memory which you, when you retrieve back, you are conscious about it. So, a task like thinking about your first birthday, I am pretty sure that you cannot remember your first birthday, but let us say your 12th class farewell or things like that. Now, another interesting thing why you cannot remember your first birthday is because there is something called childhood amnesia. We will talk about amnesia at the end of this section, but right now that is the reason, that I am just giving you the reason. So, basically conscious things which you are aware of when you are thinking about it or when you are retrieving it is what is the declarative knowledge, and procedural knowledge is those knowledge which are unconscious. So, you are basically unconscious or you do not know that you are retrieving it. For example, mostly I give this example in my classes, riding a bicycle. So, how do you teach someone to ride a bicycle? So, even if I ask you to give me how do you ride a bicycle, it is very difficult for you to show how do you ride a bicycle, and so there are two different parts. Now, within this declarative and procedural part, you have, within the declarative part, you have something called the semantic type and the episodic type of memory. We look into these two types of memory. Semantic stores world knowledge, so basically facts, rules, truths and those kind of thing, and episodic is that kind of knowledge which is basically related to a episode, which is basically related to some kind of event in your life. Procedural, basically there are 4 subdivisions, but we'll not look in detail into the procedural part of memory. I'll just give you a brief overview of what can come here. So, you have basically things which are learned from classical conditioning, things like habits, right, and so this kind of structure is there, and also priming. Priming is another thing which comes under procedural memory. So, priming is basically a instance, or it's basically a phenomena in which if you want to identify, or if you are given the task of perceiving an object, just before perception of an object, some information, some very brief information is given to you, and that brief information leads you to basically remember or basically recognize that object. That is called priming. So, basically think of it in this way. So, when you are going to meet someone, before you meet someone, somebody gives you some kind of information about that person, and that makes you quickly identify that person. Now, this information which has been given to you is basically called priming, and similarly there are 2 type of priming. One is called semantic priming, the other is called perceptual priming, but we will come to that when we come to that particular exercise, but right now this is what it is. So, let us then start the usual things. Let us start looking into the usual thing of long term memory. So, what we have done up till now is we have established that there is something called long term memory, and we have also established that this long term memory has some kind of setup which is there, which we will look into the upcoming lectures. So, basically then in this particular lecture we will look into the retrieval and encodings on long term memory. So, basically long term memory, it is basically described as a place for storage of large amount of information, and as you know from philosophical viewpoints, this has been quoted as a scrapbook of memories or a treasure chest. So, basically it has been thought of a place like a box or a chest which can store a large amount of information. So, that is what the conceptualization of long term memory is, and these are all philosophical conceptualization. Now, the question arises, what is the capacity of LTM? So, there have been several experiments which have been done, and so generally speaking the long term memory has a huge, it has sometimes it's called that it has infinite capacity. Why? Because whatever you know up till now, whatever you have learned up till now in your life, and till the point you die, it will all be stored in long term memory. So, basically meaning that most information that you know in your life is in long term memory. So, again the evidence here is that long term memory has an infinite storage. So, basically, but there have been some attempts to find out what is the capacity of this long term storage. So, let's look at this evidence. So, Thomas Lander, he tried to provide an answer by making 2 basic estimates. One estimate is the cerebral cortex has 10 to the power 13 synapses, and so what synapses are? If you look at a neuron, any neuron which is there, and these neurons, they connect to each other through an empty space. So, basically this is the neuron, this is the dendrite of a neuron. Dendrites are those portions of a neuron which help in communicating. So, these are 2 dendrites which communicate with each other, and they communicate through both an electrical messenger and a chemical messenger. So, chemical messengers are stored here, but this is something which comes into the biology of memory, and so let us not get into that particular framework, but then this synapse is the space between these 2 dendrites which are there, and so basically this space allows chemical messengers, or basically substances which are called neurotransmitters, to basically move from one neuron to another. So, if this is the neuron which is transmitting and this is the neuron which is receiving, information is passed through the synapse. So, synapse is that particular space, a void which is there, and it is very important in looking at how memory is formed. So there is a whole idea of how memory is stored, what is the way it is stored, and biological basis of memory says that there is something called phenomena called long term potentiation and long term depression, which is how memories are stored, but we will not discuss onto that. We will quickly look into this. So this empty voids or spaces are what are called synapses. And so Thomas Landier, he found out that there were 10 to the power 13 synapses in the in cerebral cortex, and which is the number of information which is stored in the brain. So he basically equated it that one particular synapse is trained for only one kind of information, and so if it is 10 to the power 13, then it is 10 to the power 13 bits of information which is stored. Huge number. Now another estimate was made as that there are 10 to the power 20 bits of information, which is the number of neural transmission made by an average human lifetime. And so this particular deduction is made on the basis of the fact that there is a life of human beings and the life of a neuron, and based on the life of the neuron and the life of the human being, it is estimated through computational calculations which show that 10 to the power 20 bits of information pass on from one neuron to the another, or that is the number of connections a neuron actually number of neurons which are there they make. And so this is the kind of information, or this is the kind of capacity of LTM. But then most of them are generically an estimate of it, and as I said, in generic speaking, it has infinite capacity. Now the question is, how does it account for this infinite capacity? So basically think of the archiving program that you have in your computer. So you have either a WinRAR, or you have something like some other I do not know the names of a lot of those archiving systems, but then you have these systems, or you have these programs which help you to compress file. Now similar system helps is there in long term memory. What it does is it compresses file, but then it uses certain features which are very advanced features. So what it does is, first it selects what information has to be stored, and based on that it also compresses information, and then it provides a key to this compression. So let us look at how information is stored and how information is retrieved, the duration and all those things in the next few slides. So basically another question is, we saw that the coding that happens, the way information is stored in short term memory was acoustic in nature, and so there was a very good experiment which was which was done by Bradley. And so Bradley showed that if acoustic words were used, if two different kind of information was fed into short term memory, and both were acoustic in nature, in the sense that either they had the same phonology, which basically means the same speech sound, and another ones which did not have the same speech sound, the confusion was more for those words which had the same speech sound. So P and D were confused more, P, D, E confused more than P and K kind of a thing. And so basically that experiment showed us, or basically told us, that the kind of storage that happens in long term memory is basically acoustic. Now what is the format in which it is stored in long term memory? So basically this is in terms of, again Bradley did an experiment and found out that this is in terms of semantic nature. So what was the experiment? So what Alan Bradley did was, he gave two groups. First he selected two groups of people. For one group he gave similar sounding word, for example map, mad and men, to people for remembering, and then he gave another words from the same list. So he gave people, two group of people, two different lists to remember. Now there are two versions of the list. In one version of the list, what happened is, people were given similar sounding words to remember, for example hen, had, heck kind of a thing, or map, madman as he are written here. And in the other list you had words from the same list, the presentation list, but then these words were not similar sounding. So you have things like pen, daring, because they don't sound similar, and this was to create acoustic confusion. And in the group B, people were given same meaning words. So you see here what happened is, you have the huge word, the big word and the great word, all of them have the same meaning. So it's like a synonym. So synonyms, generally more synonyms were given, and then another list was created where people were given words which didn't have similar meaning. So it had different meaning, for example foul, old and deep here. And recall was done after 20 minutes. Participants were engaged in unrelated tasks. So the task was basically n back counting. So an n back counting task was used. Now what is an n back counting task? We showed you in the last lecture. In the Brown Peterson task, n back counting is basically a task in which you count back n units. So 1000, and if you have to count 3 units back, it will be 997, 994 kind of a thing, and so this is n back. You have to keep on counting back, and so this is what the n back task is all about. And so people did this kind of a task. This was given so that they should, this kind of a task should take up all their available attentional resources, so that the rehearsal is not allowed or rehearsal is not given. So a 20-minute wait was done, and after that when experimenters were, or the subjects were asked to retrieve back, acoustic similarity produced very little effect on performance as well as semantic similarity. So when words which were similar, they were presented or they were shown to people, 20 minutes is enough time for any item to get processed. So when this kind of retrieval was done, it was found out that in these people, in group A, there was no difference. So there was no difference between people who were given map, and man to remember, but then more confusions were seen on people who were given similar meaning word. And so this experiment basically demonstrates the fact that these words which had similar meaning, that was what was creating confusion. And this experiment also shows that the kind of manner, or the manner in which information is stored in long term memory, is basically in terms of semantics or in terms of meaning. Another reason or another thing for the existence of semantic evidence, I would say, for the existence of semantic memory is basically, this is called Ebbinghaus forgetting curve. So what is the Ebbinghaus forgetting curve and how did it arrive? So I explained to you in earlier lecture that Ebbinghaus was a German psychologist, and he was testing his limits to memory of how much thing he can remember, how much items he can remember, and for how long a time. But if he tried to remember words from a list, then there would be some a long term memory, or there would be some bias into it. So what he did was he created a CVC, a consonant vowel consonant kind of a trigram. He called this as a trigram. So this trigram was, so let's say X, V and Q. Now X, V, Q doesn't mean anything, but PAT would mean something, or pat, or CAT would be cat. So these have meaning words, and this is a trigram. So this kind of a trigram was there. He took a lot of trigrams, he remembered them, and he then retrieved these back over periods of time. This is a very simple demonstration, a very simple thing, very simple result from his experiment. What he saw, that the percentages of mean saving and versus the retention interval, what happened is the asymptoted arrived around 31 days. After 31 days, people still remembered this 20% of items from the list. So even when he did experiments, he found out that from the list that he remembered, 20% of items were still with him. He was able to retrieve this 20% of items even after 30 days or 31 days, and which kept on going for a number of more days. So basically meaning that there is a store which allows you to store this information for longer duration of time, and that also, this idea that you do not get forgetting or do not forget after this long duration is basically another evidence for the existence of a store which stores information for longer duration time with more rehearsal. So what happens is, as time passes, you don't tend to forget more, and this is an evidence for long term memory. So let's do a quick review of long term memory. So basically the question here is, retrieval transfers information from long term to short term memory, as I showed to you, and forgetting is the inability to basically retrieve information from memory. And so people often talk about forgetting. Now forgetting from short term memory is very obvious, because items get stored for 20 seconds, and so we cannot think of forgetting as a forgetting here and there. Again, we looked at how does this forgetting happen. So in the last class we looked at the Brown Peterson task and the Vaughan Norman task, and both of them said that there is a decay kind of a thing, and interference kind of a phenomena which basically leads to forgetting from short term memory. So let's look at, why do we people forget from long term memory? How do we forget things from long term memory? So is there something called forgetting from long term memory, or if something is encoded into long term memory, does it stay there forever? So, let us look at that quickly. So, basically this is how it works. So, this is the sensory memory, this is the working or short term memory. Information is rehearsed here and then it's passed to long term memory. From the long term memory it is retrieved back as and when it is wanted back to long term memory. So, why do people forget? There are several forgetting theories which have been proposed for long term memory, and let us look at some of these theories. So, some of the theories which have been proposed for forgetting from long term memory is something called the poor encoding theory, the decay theory, the interference theory, and the retrieval queue theory. So, some of these theories are what you find. So, basically the decay and interference theory is what also applies to the short term store, but then for the long term store you have two additional theories. So, let us look at these theories one by one. So, let us look at the first theory. First theory says that forgetting happens from long term memory because people never encoded that. So, it could have happened that a piece of information was given to you and you never encoded that information, and that could be one of the reason why forgetting happened, and that could be one of the fact why forgetting happened. It could be that you never know. For example, if I ask you the question, where is the tilde key in your computer keyboard? So, people who have not used the tilde key, they have never encoded where the tilde key is, or where is the function key. So, people who type, some people who never use the function key, they never know because they never encoded it, and that is called the encoding failure theory. So, information which is never encoded into LTM is called the reason for it. There is a short term memory information never passed from the short term memory into the long term memory. So, no encoding, and that is the reason for encoding failure here. So, some examples are what letters accompany the number 5 on your telephone, if that is what is given to you. So, most of you, I mean, these days you have these newer smartphones which do not have these numbers with it, but the push button phones that were there, it had to had a number written, 3 digits or 3 letters which were written after every digit. So, if that is the question, most people would not have ever thought about that, right? And so, you do not tend to remember. Or where is the number 0 on your calculator? If this question is asked, most people do use it, and so it's become so procedural or so automatic, as we saw in attentional theories, that the thing becomes so automatic, the pressing 0 becomes so automatic that it's very difficult for you to know where it is. Or so, according to this theory, objects seen frequently but never but information was never encoded into LTM, and that is one reason for forgetting from LTM. Another reason why people tend to forget, another theory which proposes forgetting from long term store is called the retrieval failure theory. So, what does this theory say? So, it says that not all forgetting is due to encoding failure. Some of the forgetting is due to retrieval failure also. So, on one poor encoding theory, the first theory says that it was not encoded, but then the next 3 theories talk about retrieval failure. Something happens at the time of the retrieval, getting information back from long term store, and that must be the reason why this kind of a forgetting really happens. So, let us look at those theories. So, sometimes information is encoded in LTM, but it does not come back, and so you see this is short term memory, encoding is done, but it does not come back. So, these are called the retrieval failure leading to forgetting. So, what are the theories there, or what are the some common examples there? One common example is tip or tongue phenomena. The TOT phenomena is called tip or tongue. Now, there are times in your life when you know that you know information. For example, movie song is coming up, and so you are there looking at it, you know the actress's name, you know that which letter it starts from, you know which heroes she has worked with, when which movie she has worked with, but suddenly there is a freeze and the name does not come to your mouth, and this is called that tip or tongue phenomena. What happens is that you are not able to retrieve that, and that is called retrieval failure. Also, can't retrieve information that you absolutely know is stored in your memory, because you know the first name of this actress, you know whom she worked with, a lot of information, which basically means that there is somewhere also the name stored, but you are not able to retrieve it. An example I have given. So, evidence of forgetting as an inability to retrieve information. Why we can't retrieve information? that is what we are going to see. So, 3 theories from the retrieval failure section. One is the decay theory, the interference theory, and the retrieval Q theory. So, let us start with the decay theory first. And so, what does the decay theory actually says? The decay theory, this is basically the average percentage of information retrieved, and this is the interval between original learning of nonsense syllables and memory test, which is basically something like Ebbinghaus CVC kind of a paradigm. So, he looked at trigrams, and this is the curve which is there. So, basically decay theory says that memories fade away or decay gradually if unused. So, if some memory is not used for a period of time, it decays. And there is a biological explanation to that also. We will come to the biological explanation in a while, but that is what it is. So, if you do not use information which is stored in your memory, then there would be a problem. And this is something which we are seeing nowadays. What has happened is the Google has taken up so much of our information, Google has taken up so much of our life that we do not try to retrieve information. Even if we need some bits of information, what we tend to do is we tend to look into Google, we type that and we get an information and voila, it is there. So, basically that is a problem. So, we do not use it, and so I always keep on telling this to my students that please use information. If you do not use information, it will decay out. And one of the fact is the time, how much time is spent between learning and retrieving the information. That is one of the reasons of how this particular theory works. So, time plays a critical role. Now, ability to retrieve info declines with time after original encoding. So, as more and more time happens and you are not retrieving this information, decay will lead to forgetting. So, let us say at some point of time when you learn something, so there is a bit of knowledge that you learned, or Sanskrit for example. If you learn Sanskrit in your earlier classes in class 7, 8, have not used it because you didn't follow it, you tend to forget samas or things like some other grammar of Sanskrit. You do not tend to remember how the sandhi is made. That is basically conjugation of sentences, how it is done in Sanskrit. So, basically that is what happened. As time passes on, the information is never used, and so you tend to forget it. So, basically this is what the decay theory is. So, basically decay theory is a biological based theory, and so it gives a reason why decay really happens. And what is the reason? The reason which has been provided is that when new memories are formed, it creates a memory trace, a change in the structure of the brain chemistry. As a new memory is formed, from the neurobiology of memory, you will come to know that as a new memory is formed, what happens is new connections are developed. And so, when new connections are developed, what happens is there are the new dendrites get attached to each other and information passes, or one neuron gets connected to multiple neurons. But what happens is if you do not use this connections, it will wither away, the brain chemistry will take it away. So, if unused, normal brain metabolic activities will erode these connections which have been formed between two neuronal junctions or two dendrites. These connections will erode away because they are not talking to each other. So, two neurons should be talking to each other, only then a connection is there. But if this talking stops somehow, the neurotransmitter, if it stops passing between two junctions, two receptor neurons, what will happen is, or some change in metabolic activity within the synapse happens, this leads to forgetting. For example, one of the interesting thing is known which is evident is dopamine deficiencies, or dopamine deficiencies in D1, D3, D5 kind of a structure. So, these are 3 receptor types on a particular neurons, and so when lack of dopamine happens here, then people show tendencies which are very similar to neurotic people, and so this kind of a thing happens. So, if you do not use any connection for a longer period of time, it will wither away. Think of it in terms of a railway store or railway warehouse. So, in olden days, these railway warehouse used to be somewhere, and so you would see railway lines basically passing through roads. But then as time has progressed, nobody uses those railway lines or old stations or old junctions which are there, and so it withers out, nobody remembers it, and there is nobody cares about it. For example, there is New York Central Station, below that there is another station which is there, it is a popular thing which is there, and so there is a whole network out there, but nobody uses it anymore, and so it decays. And similarly, the brain also decays, the information from the brain also decays by not getting used. So, theory not widely favored today. In today's world, we do not follow this theory because there are certain brain chemistries which say that this kind of degeneration does not happen in the brain. Then you have the interference theories, and what does the interference theory say? So, memories interfering with another memories is the reason for forgetting. So, why do we forget? We forget because one kind of memory interfere with another kind of memory. Now, we looked at what is interference and we looked at how does it happen. So, what happens is that if two items which are very similar, fairly similar together are brought together, in close proximity to each other, one will interfere with the other or one will compete with the other. So, there is something called a fan effect, which has been explained by Anderson for this kind of interference. So, Anderson and Nele 1996, they did this work on how interference really works. So, what they looked at is that any retrieval queue points to a particular target. This is how they looked at. So, if this is a retrieval queue or this is how you retrieve something, it points to a target. But then assuming that another target is added to it which is similar in nature, this retrieval queue then is shared between these two targets, and so if more number of competitions are generated, what will happen is an interference will happen, because this retrieval queue C1 is now queuing these targets T1, T2 and T3, and so what will happen is when C1 is activated, one neuron is activated or one junction is activated. Now, they are not uniquely connected. What will happen is all of these targets will get activated and they will interfere with the processing of one. Now, forgetting not caused by mere passage of time. So, this theory basically says that forgetting is not basically due to passage of time, is caused by one or more competing with or replacing other memory. And so, the definition, the thing that I showed you, what will happen is multiple targets will compete with each other. So, as soon as this queue is activated, these targets will compete with each other. The more similar they are, the more chances that they will not be retrieved, because similarity is one way of how information is retrieved. So, if let us say there are, how is the conceptualization of working memory? There are different bin bags, or think of it in there are different kind of structures out there, and so structures which have similar kind of similar kind of features are put into this bin bag. We will look into that when we talk about semantic memory. And so, what will happen if informations which are of similar type, they compete with each other, what will happen is that they will not be processed. So, it is caused by one more competing with or replacing another memory. So, if similar items are there, they will compete with each other, and so they will not be able to retrieve it. There are two types of interference to look at. One is called the proactive interference and the other is called the retroactive interference, and a very simple paradigm explains it. So, let us assume that an experimental group, a group is given to learn a list A B, and while they are doing that, a control group is given an unrelated activity to do. After a while, the same group, both the groups are now given a list A C to learn. So, A B is a list, basically A B is a paired associate list. So, you have what is a paired associate list? In a paired associate list, you have something called a Q target kind of a setup. In Q target, what you have is, so let us say if we have goat and we have leaf here, the goat is what is presented to you, the leaf is what you have to remember, and this is called the paired associate. So, a pairing between goat and leaf is done, and this is called the Q and this is called the target. So, while learning you will learn goat leaf, but while retrieving I will show you goat and you have to learn leaf. Now, we have done this earlier on in attentional theory and in perception also, as a part of perception also, where we showed basically in perception, automaticity of perception, where we showed how automaticity really works. So, basically in this paradigm, then what happens is at a later period of time, you are given to learn list A C. Now, when that happens, control group shows no interference, but then since list A B and list A C has A in common, so this will interfere with each other, and so the learning of A C after A B creates this kind of a interference, and this is called proactive interference. So, here since no list was done, the learning of A B creates interference with learning of A C, and that is what the proactive interference is all about. In retroactive interference paradigm, what you have is both groups learn list A B and A B, but group 2 learn A C and the control group does not learn anything. And so, what happens here is this A C list, the learning of this particular list, it interferes with the learning of the earlier list, and that is what retroactive and proactive interference is. So, let us quickly look into what these really mean. So, when a new memory interferes with remembering of old information, this is called retroactive interference. Example is when a new phone number interferes with the ability to remember your old number. So, let us say you have changed your SIM card, you have changed your number, and when some digits in the old number the new number interferes with remembering of the old number, this is basically what is called your retroactive interference. So, quick paradigm example, learning a new language interferes with ability to remember old language. So, this person here she knows French, and these are the French words that she knows, and so what happens is after that she learns Spanish. Now, papier and papel both are for paper, liver and or pluma and plume both are for flower, and so these kind of things are there which are very similar in the two languages. And so what happens is if she learns French first, studies Spanish second, and Spanish interferes with the learning of French, that is why she gets an F in her exam, and this is what is called retroactive interference. In proactive interference, what happens is opposite of retroactive interference. So, when old memory interferes with new memory. So, in retroactive, new memory interferes with old memory, as we saw that Spanish interferes with French. In proactive interference is the opposite. So, old memory keeps on interfering with new memory, that is called the proactive interference. And so, in proactive interference, what happens is memories of where you parked your car on campus, the past week interferes with the ability to park car today. So, what happens is since you have parked this car, your car so many times near your parked your bicycle in wherever you are reading your department so many times at so many places, that interferes with the fact that where you parked today, this is what is called proactive interference. And so, this is it. So, old knowledge hampers because you tend to park at some place, and because that was not available you park somewhere else, and so the ability to go back or the automaticity which makes you go back into the place where you used to park and not finding a bicycle is what is called proactive interference. So, old knowledge basically interferes or competes with new knowledge. Now, basically as you saw, what happens here is that both the information are similar type because it is a parking situation in both the cases, and so similarity is there. Another theory which talks about the failure or which talks about how retrieval failure happens is called the retrieval cue theory of forgetting. And so, what is the retrieval cue theory? The retrieval cue theory says a clue, prompt or hint that can help memory to retrieve. So, basically when any long term memory is formed, as I said, it is a cue target kind of any kind of a memory is a cue target kind of a system. So, memories generally have something called a key lock kind of a system. So, basically when a memory is stored somewhere in the long term store, a cue or a key is provided to it, and this key fits with this lock the memory and it opens it. So, this cue is the clue or the key for the memory, and the memory is called the lock, or that is the store which is there. And so, retrieval cue is very important because if you use the wrong retrieval cue, you may not be able to retrieve. Also, another feature that you have to know about retrieval cue is that sometimes one memory can have multiple retrieval cues. What do I mean by that? If you want to remember your, let us say, farewell, the 12th class farewell. Now, if that is what you want to remember, there are several ways of remembering it. One is the kind of importance you were given there, another is the kind of feeling that you have on that day, maybe embarrassed, so that embarrassment which could make you remember that day, or maybe it was the kind of words people said to you, or the kind of feeling that you have that day, the kind of shock that you got, the kind of emotionality which was generated, and so several events can link to that memory and can bring forth that memory, and so multiple cues can link to that memory, and each of these cue has a certain weight to it. The most weighted, I mean to say the most potent cue will have the highest weight. So, basically if my memory that I am talking about is let us say remembering an event, and the event is my farewell, and there are 4 cues which can make it remember. For example, the day in terms of what day it was, how I felt that day, that is another. So, my feeling, my emotion is one way of remembering it, or it could be an let us say party, an after party which is making it remember, or some other event at home which makes me remember it. Now, let us say this emotionality is whenever I think about or whenever I become emotional, I remember this farewell. So it has the highest weight here, right? And so these have another, and so each one of them can make you think about this farewell situation, but what would happen is that this is the one which will make you the think more, and this is the highest weight. So basically what is there, and similar situation can also occur where one queue can retrieve so many memories. So there are always all types of things are there. Let's look at this theory. So retrieval queue is in this this is what a queue looks like. So forgetting the result of using improper retrieval queue. If you think about a party, and if that is what is retrieving the farewell, then what could happen is you would have so many parties in your life. So it could be the farewell party, it could be your home party which is there, it could be some other party with your friends which is unrelated to the farewell, and so on and so forth. So if party is the fact, or party is the cue that you are using to try to get retrieval, this has the lowest weight, right, because you may have so many parties, but how you felt that day has the highest weight, and so that is the most potent thing. And so if using improper cue, if thinking of retrieval in some other way in which it was not encoded, if that is what you are trying to retrieve, then that is not possible, and so that might not be a good idea of retrieving. So retrieval forgetting can be basically happening because people don't have the right retrieval cue. Now with retrieval queue, there are two things to look at. One is called the recall and the other is called the recognition. There are two retrieval types from long term memory. We will discuss this retrieval and recall in detail in the upcoming lectures, but for now let us look into it. So importance of retrieval queue is evident from recall versus recognition, and what is the difference? So recall test must retrieve information which is learned earlier, for example fill in the blank type of test. So those tests which ask you to remember something from memory, right, and as demonstrated here, fill in the blank type of questions are mostly retrieval or recall kind of a retrieval system. So here you have to retrieve the actual information which is stored, and in recognition test what happens is it's like in answers in front of you, but then you have to basically go ahead and match them. And so as you will see that recognition has recall inbuilt into it, because only if you recall something, if you are able to recall something, then you will be able to match it. So basically remember versus know kind of a thing, remember versus know kind of a system. So I remember something versus I know something. So for knowing something you have to have this remember, for remembering something you have to have the knowing kind of a thing. And so multiple choice tests are something called recognition tests. So for example, look at this question, what is the capital of Finland? Now the no answer is there, and so whenever you try to give an answer, if you ever give an answer to that, it happens to recall, because then you search your memory for it. And look at these, these are 4 answers which are given. I am pretty sure that you know the answer. The answer is Helsinki, and so the what is the capital of Finland? There are 4 answers. Now when you are recalling, you are doing a free recall, so you are searching your memory for any information, but then in recognition you have to have recall also, because you have to recall where does these things fit, and so recall basically is a part of recognition. And so this is what a recognition test looks like, and so you will put it to Helsinki, because all of them now have a probability of 0.25, 1/4 probability of being remembering. So which was easier, recall or recognition? Psychological exam, would you rather have fill in the blanks or multiple choice? And it's best that you have recognition item. Is basically multiple choice questions are what have been used nowadays everywhere, and so this is the most potent kind of examination which has been used, and so this is the most prominent kind of a recall that has been, or kind of a recall system which is used everywhere nowadays. So in this lecture we looked into some of the what is how long term memory is designed, what is the way in which it is encoded, and what is forgetting, how it is stored, and what is the forgetting from long term memory, or how does this long term memory store information. Thank you.